In today's video, I'm going to go through a couple of questions that you had yesterday. The first question is, write the equation of a transformed exponential function with a base of 5 that passes through the point 0,3. The point 0,3 is the y-intercept of the function. In general, remember that the equation of a transformed function exponential is a times the base, let's capital B, and then b times x minus c plus d. Now we know that the base is 5, so this becomes y is equal to a times 5 exponent b times x minus c plus d. We know that the y-intercept is 3, meaning when x is 0, y is 3, so when y is 3, x is 0, so it's going to be b 0 minus c plus d. If I simplify it, I get 3 is equal to a 5 minus bc plus d. Now this is an equation in 4 unknowns, a, b, c, and d. And to uniquely find a solution, I need 4 equations, and I don't have it. This means that the solution I find is not unique. So that's the second part of the question. Is your solution or equation unique? You say no. Now, the first part says write an equation. So to write an equation, let's pick a number here. Let's say a is equal to 1, c is equal to 0, b is equal to 1, and d is equal to 2. Let's see what will happen to equation. If I put these values in the original equation, I get y is equal to a 1 times b, we said the base is 5, then b is 1 again, this b, so I get 1 times x minus c 0 plus d plus 2. So if I simplify it, I get 5 exponent x plus 2. Now this is one equation. Let's try to see if it's correct. If x is 0, 5 exponent 0 is 1, so 1 plus 2 is 3, so it goes through to this point. Now you may say, okay, give me another example. Let's say the second solution, I can say, let's say a is 1, let's say b is 10, and let's say c is 1 over 10. Again, these are random numbers here. Let's see if I put these values, what is d value now? To do that one, my equation first becomes y is equal to a, which is 1, times b is 5, exponent b 10, x minus c, x minus 1 over 10 plus d. To find d, I know that it goes through this point. So if I set y is equal to 3, 5 exponent 10 times 0 minus 1 over 10 is minus 1 over 10 plus d. Now 10 times negative 1 over 10 is negative 1. 5 exponent negative 1, remember previous lesson, it becomes a negative exponent, so this becomes 1 over 5. So 3 is equal to 1 over 5 plus d. If I move this one to the left, I get d is equal to 3 minus 1 over 5, which is going to be, if I multiply this by 5, divide by 5, I get 15 over 5, minus 1 over 5 is 14 over 5. So my second version of the equation is y is equal to 5 exponent 10 x minus 1 over 10 plus 14 over 5. So these are two different versions. I can come up with so many versions as I want. This means that this equation is not unique. The next question that you had was how to solve this equation. If I'm correct, I covered another type of example like this one before in the previous video, but I'm going to do this one again. To solve this one, I move this one to the right, so I get 7 exponent 6y plus 4 is equal to 8 exponent 5y. Take the log of both sides, I get 6y plus 4 times log 7 is equal to 5y log 8. Now I distribute the log inside the bracket and move this one to the left. So I get 6y log 7 plus 4 log 7 minus 5y log 8 is equal to 0. This one and this one, they have y in common, so I factor y. I get y times 6 log 7 minus 5 log 8 is equal to, and now I move this one to the right, negative 4 log 7, and then I divide by this, both sides, so I get y is negative 4 log 7 divided by 6 log 7 minus 5 log 8. This is the exact solution. To find the approximate solution, we use the calculator, and this becomes approximately negative 6.1.